Hi everyone, it's Coach Fred here, and today I'm going to be taking what you learned about the sine and cosine graphs, and we're going to be making some changes to the graph. We're going to be translating and transforming them. So I'm going to go back to the three definitions that we learned in our previous discussion on these. So those definitions are amplitude, period, and frequency. Okay, so the amplitude, as we said yesterday, is half the distance between the max and min on the graph. So half the distance between the max and the min. So you're going to be looking for that high point of the sine and cosine graph and that low point, and you're going to take half the distance between them. Now, in the function y equals a sine bx, actually, let me make this a little bigger. Y equals a sine bx. That absolute value of a is actually going to show me the amplitude. So if it's 2, that means that half the distance is 2. Same thing here in the cosine graph. Y equals a cosine bx. The absolute value of a is going to tell me the amplitude. All right, now remember we talked about period. Remember, period we talked about, we came up with the definition, it's the length on the x-axis, the length of time it takes for one full cycle of the graph. One full cycle of the graph. And we talked about that the general rule for sine and cosine is that the period is always going to be 2 pi. All right, now I'd like to talk about frequency. The frequency is how many times the graph completes a cycle in 2 pi, in its period, during that time, during its period. And so we can tell our frequency from the b value here and here. B tells me the frequency. Now, if I want to find the new period, we're going to learn something new now, okay? So here we have some translated functions. So y equals 3 sine 2x. Now we do have to have some understanding of our sine graph. We know that sine starts at 0 and kind of goes like that. That's one full period of the graph. And cosine starts up high at the top, so at 1. All right, so first I want to identify my, my amplitude. Okay, so my amplitude is 3. All right, then my period. So I know that my period is 2 pi. But now this frequency means that it's going to happen twice in 2 pi. So it's going to be faster, like that. So I'm going to see it happen twice. So the period actually gets shorter. So to find the new period, you're going to do, so our new period, you're going to do 2 pi divided by the frequency, so divided by b. So in this case, we would get 2 pi over 2, and our period would be pi. Now, remember, when we go around the unit circle, we have 4 equally spaced groups. We're going to go around 4 times, and on the graph, we saw those 4 symmetrical sections to the graph. So we need those 4 symmetrical sections. So I'm going to teach you something new now. I like to take the period and find the quarter period. Why? Because there's 4 quarters. So the quarter period here would be pi over 4. So that means that every one of my tick marks, 1, 2, 3, 4, and then 1, 2, 3, 4, are going to be units of pi over 4. So the first one would be pi over 4. The second one would be 2 pi over 4, which is pi over 2. The next one, 3 pi over 4. The next one, 4 pi over 4, which is pi. The next one, 5 pi over 4. You see why I want quarter periods? 6 pi over 4 would be 3 pi over 2. 7 pi over 4. And then 8 pi over 4 would be 2 pi. Now remember, I could go in the opposite direction as well. And we would just call those the negative angles, right? So negative pi over 4, negative pi over 2, negative 3 pi over 4, and so on. Okay, then we want to put in our amplitude. Our amplitude is 3, which means that from the midline, remember this line right here, we call the midline. it really is going to always be 3 units up from the midline and 3 units down from the midline. So I'd be up here at 3, and then I would be down here at -3. Okay, so now I just have to think about my quadrantal angles. So remember, when we're dealing with sine, my quadrantals, our coordinates are 1, 0, 0, 1, -1, 0, 0, -1. Okay, so sine is my y values, so that means I'm going to start at 0. The graph starts at 0. Actually, let me do it in blue. And then it goes up at pi over 4 to 3, back down to 0 at pi over 2, down to -3 at 3 pi over 4, and then back to 0. And then up to 3, back to 0, down to -3, and back to 2 pi. If I go in the negative direction, now from 0, I'd have to go down to -3, up to the midline, up to 3, down to the midline, down to -3. And you see that it's going to just keep going and going like that. All right, so I'm going to try to get my graph in here really pretty. Oops, lost it there. Okay, so now we can see that the graph actually, half the graph, the graph happens 2 times in 2 pi. If I think about this being my starting point and I get to 2 pi, I got 1 loop, 2 loops, so a frequency of 2. But you can see that the period changed to pi, meaning the graph, it takes pi units along the x-axis for the graph to go through 1 full cycle. Okay? All right, let's look at the next one. Same idea. First, identify your amplitude. So my amplitude would be 3. My new period, again, let's see, it would be 2 pi over a half, which would mean 4 pi. So this graph's going to get stretched out. And so my frequency is a half. So that means half the graph is going to take place in 2 pi. All right, so let's get my quarter period. So my quarter period would be pi. So I'm going to do 1 pi, 2 pi, 3 pi, and 4 pi. And then on the other side, we're going to do our negative values. So -pi, -2 pi, -3 pi, and -4 pi. And I hope you're seeing why I'm using this idea of quarter period. It's just going to help you when you are trying to find the values where, kind of where the quadrantals should be once we change the period, but where we want to put our tick marks along the x-axis, which actually can be challenging when you're doing these trig graphs. Okay, then I'm going to go ahead and put in my amplitude, and sine, again, starts at 0. So then I'm going to go up to 3 at pi. And then at 2 pi, I'll be back to 0. So you can see that's actually the period. So you can see the top part of the graph occurring. And then down, and then up, and then down, midline, up, and down. So while I made the scale kind of look pretty similar to the last one, you can see that only half the graph has occurred between 0 and 2 pi. And that's what our frequency was telling us. All right, so what I'm going to suggest you do is try the same thing with cosine, and then come back and check your answers. All right, so very similar to the ones we did, getting your amplitude of 3, frequency of 2, period of pi, and quarter period of pi over 4. All the labels on the first graph would be the same, except we have to remember that cosine starts high, so it would start up at the amplitude of 3 and then work its way down and up. So remember, that's really the only difference between sine and cosine. Sine starts at the midline. I always like to say cosine starts high, so at the amplitude, the high amplitude. All right, so checking your answers on these 2 graphs. So the last thing I'd like to look at is what happens when I put a negative in front of the function on the outside of that function. You can see I have y equals negative sine of x. So really the only thing that's going to do is going to reflect it. It's going to reflect it over the x-axis. Okay, so I do want you to go back and look at your sine graph. The sine graph, we know that our basic y equals sine x has a period of 2 pi. And so that means our quarter period would be pi over 2, which we know from our graph is all the quadrantals. So pi over 2, pi, 3 pi over 2, and 2 pi. And the same in the opposite direction, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. Okay, my amplitude is 1 because remember amplitude is absolute value because it's distance. Now the only difference is I know where my midline is, so I always like to see my midline. Sine starts in the midline, but instead of going up here, it's going to go down to negative 1, then up to 1, and then down. And so on the other side, it's going to go up to 1, down to the midline, down to negative 1, and then up to 2. So you can see it's just a graph of the sine curve reflected over the x-axis because the regular sine curve would look like this. And so hopefully you see that reflection. All right, guys, that's it for today. Hopefully that was a helpful video. Now I want you to go on to the practice on the next pages and check your answers on 34 to 36. Check your answers on the Note Packet Solutions. Have a great day.